So guys, the first problem is the name of the first problem is gift carpet. The problem says that recently Terma and Vika celebrated family day and like some random stuff, which like at last you can see that in the carpet there are n rows and m columns and into m table. So which it means that there are n rows and m columns. And Vika has not seen the gift yet, but Tema knows that what kind of carpet she likes. Vika will like the carpet if she can read her name on it, and she reads column by column from left to right. Choose one or zero letters from the current column. So it means something like this: that if the carpet is, let's say like this, having some columns and some rows. So what will happen is that Vika will read the whole column first. If there is any character like V here, then she will move on to the next character, next column. It's up to her if she like if she finds a V, then that's good. If she doesn't find any V, then speaking language. Let's see. Wait a minute. Okay, so let's come back, or maybe let's read the problem first. Formally, the girl will like the carpet if it is possible to select four distinct columns. You have to select four distinct columns from here. In order from left to right says that the first column contains V, the second column contains I, the third column contains K, and the fourth column contains A. So she will read the whole column and she will either take one character from the column or doesn't take anything. So either take something or doesn't take anything. And in this way, she will choose four distinct columns. And from every column, she will have one character each. So she want to have something like Vika formed. Guys, did you understand this problem or shall I repeat? Shall I
Uh,
repeat or is it fine?
Repeat. Repeat. I mean, repeat it
Okay,
again.
repeat. Okay, no problem. Let me repeat it once again. Um, let's come to OneNote instead. So what the problem says is that there is a girl with name Vika. She has been given a carpet as a present. In the carpet, you are having some columns and some rows like this. It is like a table. Vika wants to choose four columns. Like you have to tell if it is possible to choose four distinct columns, such that the first column has V inside it, the second column has I inside it, the third column has K inside it, and the fourth column has A inside it. This is the problem. They have just written the same thing inside a story, and they have explicitly mentioned this thing here, that the story is actually trying to ask this. So is the problem clear now in simple words?
Yes, Raghav. It's clear.
Okay, that's good. So, so not necessarily first, second, third, fourth. No, it's not first, second, third, fourth. These four columns can be any of them, but
Yes.
the among the four columns, the first column among these four chosen columns, the first one should have I, the second one should have like first one should have V, second one should have I, third one should have K, and the fourth one should have A.
Raghav, is it
So this
necessary
is
that
the
there
problem.
should be four
Yeah.
columns? Is it necessary that there should be only four columns, or there can be any number of columns?
The chosen columns should be four only because the name consists only of four characters. So if you choose five columns, it doesn't make any sense because like let's say you chose VIKA from here, but why did you choose the last column then? So if you try to think about it, you will realize that we can choose only four columns.
Yeah. Okay. Okay.
Yes. Yeah. So the approach is very simple. Like just try to think about it. Let's say the first column is having a V somewhere. I have two choices. Either I pick it or I don't pick it. Either I choose it to be among the four distinct columns, or I don't pick it. Which means that I just go to the next column. So in case if I choose it, I would have to pick up just I, K, and A from the remaining matrix, right? But if I don't choose it, in that case, I would have to find the whole string, Vika. So not choosing it doesn't have any benefit, right? If you don't choose it, you won't have any benefit. Like in case if you choose it, you will have a benefit that you now don't need to search for this character and you need to just search for the remaining string. Yes, I will discuss the problem D also. I will discuss the problems A, B, C, D, and E and F. So looking at this problem, like we just have to traverse the matrix in this way from like the whole column first, then the second column completely, then the third column, then the fourth column. In any column, if you find a character, like at first if you find V, then you will pick this column and go to the next column. You won't try to search any more characters in the same column. And the next time you will be trying to search for I, then for K, then for A. And since we have to search in this way, either you can maintain like a string with VIKA and an index in time D. Initially it is 0 and you just increment it. Or other lazy way is just use a queue of characters and just keep popping out the first character whenever you find it. So I hope that the problem and the approach is clear to you guys. Shall we move on to the code?
Yes, sir.
Okay. Okay, I see a lot of yes. So let's move on to the code. For the problem like this one, there can be a lot of ways of implementing the problem, implementing the code. The one which I used during the contest was that first of all, I'm just taking the inputs. Till here, I'm just taking the inputs, nm and the vector of characters. After that, I declared a queue or and inside this queue, I pushed on vika. So like either you can use a queue or you can use a vector or a stack. If you use a vector, then either use an index with it or just reverse it. Obviously, there can be multiple ways. The one which I used was to use a queue. And then I traversed over this matrix column by column, like traversing the first column first, then the second column, then the third column, and so on. And in any column, if I find the current character to be equal to the front of the queue, element on the front of the queue, then I will just pop out the element from the front of the queue and move on to the next element. And apparently, I think that I made a mistake during the contest. There should be one more condition that if queue is full, then just pop. So in my code, I think, I don't know how it passed. I think that there should have been one more condition after this line, that if queue dot empty, then like q dot pop. Sorry, not q dot pop, but break. This should be the condition. Yeah, I think that the people attending the meeting will actually hack my code. So feel free to hack it. I don't really care since this is unrated and you might get some bonus points. So this is the mistake. Okay. I'm not sure if you can hack my code or not. I was not in the competition. And like since it was not rated, so I was very chill and didn't really focus much during the contest. So here I hope that you got the approach, that you are having some rows and some columns. You are going for the whole column first. As soon as you find the first character to be equal to the, like any character to be equal to the first element of the queue, just pop out the element from the queue and move on to the next element. And keep repeating this until the queue is empty, or you just traverse over the whole matrix. And at the end, you can just check if the queue is empty, then print yes, otherwise no. Shall we move on to the next problem then? Shank, the extra condition is that here the problem which can happen is that if Q is empty, then Q dot front doesn't have is not there, and I think that it will give an error if you try to like if you try to check for Q dot front when Q is empty, then it can give an error. So there should have been a condition that if Q is empty, then just break. Yeah, so shall we move on to the next problem? Just please write inside the chat yes or no. Okay, so there are a lot of yes. Let's move on to the next problem then. So in the next problem, sequence game, it says that Tama and Vika are playing the following game. First, Vika come up with a sequence of positive integers a of length m and writes down on a piece of paper, and like you can read this line. So the problem in a nutshell says that Vika has an array a of length m. She will first of all write down a1, and then she will write down all the elements from like in the remaining subarray, in the remaining array, which are greater than or equal to the previous element of that element. So she will write all of them. And then the new array which she have, she will just give it to Tama. She will just give this to Tama. And now Tama has to construct any sequence A which will have the answer, like which can be equal to A. So let's go to the notepad and here see that. So here it says that, let's say the string, the array is something like 1, 2, 3, 1, 4, 2, 6, something like this. Vika will first of all write down this number, whichever comes at the first place. Then for every number, it will check whether it is greater than or equal to the last element or not. So here 2 is greater than 1, so she will write 2 also. Then checking for 3, 3 is greater than 2, so she will write 3 also. Then she will check for 1. 1 is not greater than or equal to 3, so she won't write this 1 here. Then she will check for 4. So 4 is greater than the previous element, which is 1. So 4 will also be written here. Then checking for 2. 2 is not greater than equal to 4. So 2 won't be written here. And then checking for 6. 6 is greater than 2. So 6 would also be written. Let's say the array consisted of 1 or 2 also. So she would check for 1. 1 is not greater than 6. So it won't be written here. Then checking for 2, which is greater than the last element. So 2 would also be written here. In this way, you will have from the array A, this this was your array A, from which you constructed this array B, and it would be given to Tama. And basically here we have to do the work of Tama. So we will be given this array, and we have to create any array which when like done the same operation, that writing down the first element and all the elements which are greater than the last element, will get the array B. So since we are not being given array A and there can be multiple arrays which have um, which can form B array B, so we have to guess any one of them. Is the problem clear to you? Just write yes or no inside the chat. Is the problem clear? Okay, so that's good.
Hello.
Okay, so yeah.
You haven't told the approach yet, right?
Huh?
For this one. You haven't told the approach yet, right? For this one.
No, I haven't told about the approach. I've just discussed the problem
Yeah.
here.
Yeah.
Yeah, I'm going to discuss the approach now. So what like this was an observational problem, or maybe you can say a constructive algorithm problem, where you have to come up with a pattern or an approach which is not like which is not something very standard, but you have to think at the moment when you like face the problem in the contest. Here the approach with which I came up was that this first element is definitely the first element of A0. I don't really have any choice. So just write this inside your answer. Then you see this next element. What if I just place it ahead of this one? I will definitely get it in array B because this is larger than the last element. Do this again. Check for the next element whether this is greater than or equal to 2 or not. If it is greater than 2, then you can just write it here because you know that this element will indeed be printed like be included in the array B since it is placed after an element which is smaller than this, right? Try to think about the intuition, like try to just notice the way I'm coming up with it. Checking for the next element. Again, this next element is greater than the last element of my array. So can I say that if I place it here, it is greater than or equal to the last element. So it would also be included in the array B. Now coming for the next problem, again the same thing. Now coming up to the next element, which is less than 6. So if I just place it directly here, and if you try to like if you assume this to be our array A and try to create the array B as stated in the problem, we will only have 1, 2, 3, 4, 6. You won't have 2 there, but you want to include 2 also. So what you can do is just insert a dummy element like 1 here, or maybe you can just print it like include this element twice. You can do anything. Just have any element which is smaller than this 2 here. How are you so sure that it won't affect your answer? The reason why I'm so sure that it won't affect my answer is because if this 2 is not greater than the last element, then this element 1, which is even smaller than 2, would definitely be smaller than the last element. So I can easily place this 1 here, and then I will have 2 in the array B also. So guys, did you understand this? Okay, that's cool. And talking about the intuition, the way I got to know about this approach, like the way I thought about it, I just thought that something like, let's say there is something like 5 in the array B. There is something like 1, 3, 5, 2, and then 7. So I just came up with an idea that what if I place 1 before every element? Like instead of the first element, I will place 1 everywhere. I just thought about it. So I thought that, okay, after this 5, the next element will be small. So you can have 2 here. It will just include this 2 and ignore this 1. If you include a 1 here, so this 1 will be excluded, will be ignored, and the next 7 will be included. It is true everywhere, but in case if the last element is 1, in that case, this 1 won't be excluded. I have not really explained about the intuition because intuition is something you just need hints for, and then you have to think about it yourself. So the basic idea was that if I want to have something like 3 and then 5 in the array B, if I have something like this, I can have 3, 1, 5 in my original array. And this is going to be valid for every number unless the element on the left side is 1. And from there, I came up with an approach with an idea that why don't I just generalize it that if the next element is greater, then there is no need to include this 1. And if the next element is small, let's say if the next element is smaller than the previous one, then you can include a 1 here. So is the intuition like, did you get some intuition? 2 is also possible, right? I didn't understand, Shank. What did you try to ask? But
I was what I was thinking, like between every 2 elements in the sequence
yes.
that is given. So whatever the first element will be here, like at the index 0 and 1, let us take an example. So I'll just reduce the 1 out of that and I'll insert between that 2 elements.
So you are trying to say something like this, that have AI, then AI minus 1 as the next element, and then have AI plus 1 here. Something like this.
Yeah, exactly. And if it's 1, if
But
suppose AI will be 1 at that time, I will insert.
Okay, so if this element is greater than 1,
Because
I
it
think
is
that
given,
your
right?
approach is
It should.
also the same of what I did. It's
And as it is given, right?
I think that
It
your
can be
approach is
less.
also pretty much the same. It can be less. You want to find not between the week and not exceed this. But in the problem, it says that the integers we print should be inside the range from 1 to 10 raised to the power 9. And
Yeah. So whenever
I
I
think we can discuss
encounter,
your approach at the end of the session.
okay.
Yeah, I think that we can discuss about your approach at the end of the session. And mine seems to be like easy, I guess. So guys, shall we go to the coding part, or
Uh,
do I
Can
need to
you check
repeat the
the
approach?
one test case 2351 with your approach?
Okay, 2351. By the way, guys, whenever you have to, like, whenever you want to ask for any test case, you are always welcome. Because it is gonna be helpful for everyone. If you suggest a test case, you can just write it in the chat whenever you have. So looking for this one, I will include 2 for sure in my answer array. Then 3 is larger than 2, so I can just have it here directly, because this 3 will definitely be included in the array B when you try to make up array B from answer. Again, the same thing, 5 is greater than 2, so just include it. Now this 1 is less than 5. This 1 is less than 5, so I need to insert a 1 here. I can't directly have, like, if I just insert a 1, then it won't be included there. So we are inserting a dummy 1 also. So this will be the answer, and it's totally valid. We can just confirm this. So shall we move on to the coding part? Can you please try and for and okay. Yeah, so there is one more test case somebody gave, that if the array is something like 1 comma 1, what will we do? So for the first element, it's definitely gonna be included in the answer array. Second element is equal to the first element, so we can safely add it again, because we want it to be greater than or equal to the last element, and that's our answer. 1 is our answer here. Okay, so now let's move on to the coding part. So what I did was to first of all take the inputs, and after taking the inputs, I declared a vector, like a vector of integers with name answer, and initialized it with just size 1, which is having the first value of the array. And then I iterated over the remaining array and said that if the current element is less than the last element of the array, then insert a dummy 1, otherwise no need, and then insert the current value. So it's the same approach which we discussed, that let's say that the array A is something like 2351. I said that in the answer array have 2, then check it is greater, so have 3, it is greater, so have 5. Now this is not greater, so just insert a dummy 1. This is a dummy 1, and then insert the original value also, and in this way we'll have your answer. I hope the approach is clear to you all. Shall we move on to the next problem?
Yeah.
Okay, that's cool. Now for the third problem, it says that Anya lives in a flower city by order and some random stuff. And then it says that the fence consists of n planks, each of height AI. And according to the order of heights, the planks must not increase. In other words, like the given order may like ensures that it is either decreasing or same, which means that it is non-increasing array. So let me show what I mean by non-increasing array. Non-increasing array means that for every element after A0, the A1 will either be less than or equal to A0. Then the same thing for A2, same thing for A3, A4, and so on. So in general form, like in generic way, you can say something like this. If you pick up any I less than J, then AI will either be greater than or equal to AJ. This can be said mathematically. This is like the constraint on the given inputs. And then we have been told that Anya becomes curious whether the fence can be symmetrical in order with respect to diagonal. In other words, she get the same fence if she lays all the planks horizontally in the same order. So it's something like the planks are initially like this one, either increasing or same. Now Anya will place them like this. The largest one has been placed here, then the next one like here, then the next one, then the next one. This one is here and this one is here. And the point is, what she wants to ask is that these two should look equal, look same. Both of these should look same. That's what we have to check. If both of them look same, in that case, it will definitely be diagonally symmetrical. How am I able to say that it would be diagonally symmetrical in this way? It's because I have something like this, which I rotated to like folding it. This point comes here and this point comes here. So in 3D, you can think about it to be something like folding it in this way. Like I don't think I will be able to show you visually.
Maybe
I
you
have
can
to.
give the base and that horizontal height something 4 or 3, then turn it. It will look easy.
Okay, yeah, good idea. So let's say if it is something like 4 here and 3 here, and I rotate it, so it will become something like this. This thing, where the height is now the base and the base is now the height. And obviously it won't be a triangle, it will be something like this. So the thing which I'm saying is that if both of these are equal, it means that it would be diagonally symmetric. And this is something you can try to prove on your own. Yeah, rotates by 270 degree. And so something like that. Not exactly. And we just have to tell this much. Like the problem is only this much. So guys, is the problem clear? Please tell me yes or no.
Yes, it's clear.
Okay, that's cool. So what I want to say here is that the maximum value of n can be only in this range, 2e5 till 2e5. N can be less than or equal to 2 into 10 ki power 5, right? Let's say if the first element, which is the maximum one, is something like 3 into 10 ki power 5 or any number which is greater than n, will it ever be possible?
No.
It won't be possible because the height is way more than the number, is way more than the base. Here the base will be equal to n, and the height is gonna become something like a0. If this a0 is greater than n, then I can directly say no. And obviously if this a0 is less than n, in that case also I can say no. It should be equal to n only. I've been getting some intuition that when I place them horizontally like this one, placing them like this, the thing which matters, so let's move it. So the thing which I want to say is that this height, this height should be equal to this one. this one should be equal to this one, which we can see here that it's not correct, but it should be something like this. And at the end, this height should be equal to this height. If this condition holds, then I can directly say that, yeah, my answer is like the answer is good. The plank is diagonally symmetric. The set of planks is like diagonally symmetric. So let's do one thing. First of all, let's find the frequency of every size of plank. So let's take an example here. Let's take an example. If the first plank is of height 5, the second plank of height 4, the third one of height 3, then height 2, then height 1. 4, 3, 2, 1. When I place them horizontally, it would look something like this. Height 3, height 2, and height 1. Right? It would look something like this. So I can know one thing. I can notice one thing here, that all the planks of the height of 1 or greater than that will be like, if I can find it, this will be the height of like this will be this height. Guys, can just try to figure this out. Just try to see this. What is the height of this level, this column, or the column which I have marked here?
5.
Let me use this one. Yeah, it's 5. This is 5. And you can try to notice, this, that it will be equal to the number of planks with like initial height. I'm talking about this height right now, with AI greater than or equal to 1. All the planks with the height greater than or equal to 1 will be here. In the next one, in the next column, we will have all the planks. Like right now we are having 4 planks. These are all the planks, or the number of planks with AI greater than or equal to 2. Right. Then for the third one, you will have 3 here, which is the number of planks with AI greater than equal to 3, and so on till the last element. So, Wes, did you understand this? Did you understand this thing which I told just now about the height of every like level of the plank, every column?
Can you explain once again?
Okay, so let me explain it once again. Let's do one thing. Instead of assuming it like a plank of height 5, let's assume that these are 5 blocks combined together, attached together. These are 4 blocks attached together, 3 blocks attached together, 2 blocks attached together, and 1 block attached together itself. And for these thing also, so initially the planks you have looks like this one. 1, 2, 3, 4. So let's add one more. 5, 4, 3, 2, and 1. Right. If I place it horizontally, it will still look like this for this example, that a plank of 5 blocks at the bottom, 1, 2, 3, and 4, 5. Then a plank of 4 blocks. Then a plank of 3 blocks. Then a plank of 2 blocks, and the plank of 1 block. Right. Now, I've reduced the problem. Like I'm just trying to get you visualize the problem in this way. Now I just want to compare the number of these blocks equal to these blocks or not. I have to just check this thing. So for checking this thing, I can do just one thing very easily. Someone is asking something. Even I pose the problem, but right. Okay, we will come up with. I just want to compare these two things, whether are they equal or not. For finding the number of blocks here, I can just easily say that this is equal to A0. For finding the number of blocks here, I can say one thing, that these are all the blocks such that the AI is greater than or equal to 1. Checking for the next column, you can say that these, like I have it in A1, the given array. For this one, it is the number of blocks such that AI is greater than equal to 2, and so on for the, like all the levels, like all the columns. So is this clear now? Okay.
Clear.
You want me to explain it once again? I think that I can give a overview now. So the problem which I had said that I have some planks of some heights being given to me. Now, for making the problem easy for you, I said that instead of assuming them like a plank of height AI, assume it to be like a plank with AI number of blocks. AI number of blocks. So it will become a little easy for you to visualize. Now, let's say we are talking about when the planks are of this much height. 1, 2, 3, 4, 5. The next plank like this. The next plank like this one. The next plank like this one. And the next one, this one. It would look like something like this if you assume the plank to be consisting of AI number of blocks. If you lay off all the planks in the horizontal way for like 5 blocks, 1, 2, 3, 4, 5. Then 4 blocks, plank with 4 blocks, then the plank with 3 blocks, then the plank with 2 blocks, then the plank with 1 block. Both of them should look same. And here we can see that both of them are actually looking same. Now, like obviously in the code, you can't say that they are looking same. You have to check it. Like you won't be able to see them. You would have to check them. So here what we can say, what we can do is just find this height and this height. Obviously, the first thing we would be checking is the number of columns here. 1, 2, 3, 4, 5, which is 5 here. It would be equal to n. And for this one, it would be equal to a0. So one thing we can surely say is that a0 should be equal to n. Otherwise, the answer is directly no. Now for finding this height, you can just directly say it is equal to a0 because it has been like explicitly mentioned in the problem. For finding this height, you can just check all the columns of height greater than or equal to 1. All the columns with a height greater than or equal to 1 will be here in this column. All the columns with the height greater than or equal to 2, all the planks actually with the height greater than or equal to 2 will be coming till this column. For all the planks with a height greater than or equal to 3 will be coming till here for 4 and for 5. Now, when I want to compare these planks, I can just compare A0 with, let's say B1, where B1, like BI, tells me about the number of planks with AI greater than equal to I. AJ greater than equal to I, where J is this thing. Basically, with height greater than equal to I, in simple words. Height greater than equal to I. So is it fine now? Guys, did you understand this intuition? And shall we move on to the coding part now for this
Yes.
problem?
Yes.
Okay, that's good. So let's come to the coding part. This is pretty simple, I think. First of all, we can just take up the inputs. This you can just ignore this mx stuff. You don't really need to find the maximum since in the problem it is mentioned that maximum will be present in A0. I didn't realize this during the contest and wrote some redundant code. After this, I just check that if mx is greater than n, then directly say no. Otherwise, you can even check this, that if mx is not equal to n here. And in case if you don't check for mx less than n, there is no problem. We will get it wrong in this line, like in this condition. But for now, this condition is must. You must be checking this much at least. Someone is asking something, I think. Can you tell me how to think of edge cases? Because I was able to solve it will come up with practice. You will be able to think about test cases with practice. When you get a lot of wrong answers a lot of times and you try to think a lot, you will come up to cases and you will become better. Okay, so now creating this array bi, which we discussed earlier, where bi will be storing the number of planks with height greater than or equal to I. First of all, what I did was just found the frequency of every plank, how many times a plank of height ai has been coming, and then I just iterated over the array from the back side to like it is something like suffix sum array. So let me give an example. I wanted to find the number of planks with height greater than equal to ai, like greater than equal to I. So first thing which I did was to just find out in the bi, I just stored the number of planks with height I. Then I set for the plank with height n minus 1, the number of planks with height greater than n minus 1 or equal to n minus 1 will be equal to bn, like b starting with height n. The number of planks with height greater than or equal to n will be bn. For n minus 1, it will be equal to b of n minus 1 plus bn. For height n minus 2, it will be b of n minus 2 plus b of n minus 1 plus b of n. So instead of calculating this thing again and again for all of them, what I did was, after checking this thing, I just said that b of n minus 1 plus equal to b of n. So b of n minus 1 will now store this whole thing. Then when you say for b of n minus 2 plus equal to b of n minus 1, it will store this whole thing. And in this way, we are gonna be able to find it. Or if you're not able to understand it, how I thought about it, you can just simply create a suffix sum array. You can simply create a suffix sum array and it would be good enough. And after that, I'm just checking that if ai is not equal to bi, in that case, the answer is no. Here, this ai.
With that suffix sum array, can you just take this test case and do that same thing just once in a fast way?
Yeah, I can take up the test case, for example. Before that, let me just tell you about what we are storing inside bi. You already know that the height of these blocks is stored inside ai by the problem itself, and the height of this, the number of blocks with height greater than 1, like planks with height greater than or equal to 1, we have stored it inside b of 1. And for this one, we have stored it inside b of 2. So we can just simply compare these. And instead of, we will come to it also. So now let's take an example first. Let's say that the array is something like 5, 4, 3, 2, 1. Array b, like b0. Let's see. Let's say the array is b equal to 0, 0, 0, 0, 0, and a 0 here. Index 0, 1, 2, 3, 4, 5. Now here I can say that when you see like 1, 1, all of them are present only once. So you will make all of them equal to 1. You will just iterate over all of them and increment them one by one. So you found 1, you found 5, so incremented 5, you found 4, so incremented it 4, found 3, incremented it 3, found 2, incremented it 2, and the same for 1. Then you don't really want to store the number of planks with height 3. You want to store the number of planks with height greater than equal to 3 here. The same for everything. So what I said was that instead of storing 1 here, store the number of store this sum. And for storing this sum, I just add the next element here. It will become 2. Or let's make it even easy. Let's, instead of making changes inside this array, let's create a new array with name suffix sum array. And inside the suffix sum array, you will obviously start from the end. You will put up 1 here. Now this 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, 4, 1 plus 4, 5, 0 plus 5, 5. This is nothing but suffix sum array, which I think that all of you already know about. In case if you don't know about, then you must study about it before solving the problem. And like in my code, instead of creating the suffix sum array, I just stored everything inside the array B itself by saying something like B of I plus equal to B of I plus 1. But you can create a suffix sum array if you are not able to if you're not feeling it easy to do it inside the suffix sum array. So is it clear now?
Yeah, like this B array is same as suffix sum array. So can you just take a one test case like 55533?
55533.
Yeah.
55533.
Yeah.
So the array B will initially be 0, 0, 0, 0, 0, 0. After iterating over it once, like 1, 2, 3, 4, 5. So after iterating over it, you will see 5 is coming 3 times. It would be 3 here. 3 is coming twice, so it would be 2 here. Now, when you create a suffix sum array inside this array B itself, you will see 3 here, 3 here, 5 here, and this 5 here, 5 here, and there's 0 here. Sorry, 5 here also. Now you can just compare these values with these values.
Yeah, it got clear. Thanks.
Yeah, that's good. And someone is saying that he used a prefix sum array. So yeah, you can use a prefix sum array also. There can be multiple ways of implementing the problem. I implemented it like suffix sum array. And like after creating the suffix sum array inside array B, I'm just checking for every element if the elements are equal or not. And please notice that here I've been using 1 based indexing for the array A. In case if you use a 0 based indexing, then you should be using like writing A of I minus 1 here. This is again something which you can already do on your own. So shall we move on to the next problem? Okay, let's move on to the next problem. Ice cream balls. So the two, three things which I wanna point out just by like looking at the problem. First of all, let's read the problem statement. So I think that at this level, if someone is coming up till the D problem here, he or she must be able to himself at least understand the problem on his own. So I will be reading the problem very briefly. Tama decides to improve the ice cream making skills and random stuff, and he can make up ice cream in a cone using at least 2 balls. Let's leave this. So here we have to find minimum number of balls Tama needs to make exactly n different types. Exactly n. So the number of type of ice creams which Tama can create should be no more than no more than n, or no less than n. It should be equal to n only. And then it has been mentioned that let's say that he is having a set of flavors as 1, 2. Then okay, so sorry. In this, they have been telling that 1, 2 and 2, 1 will be considered the same, and they will be considered different only if there is some element which is different in both of them. So the pair should be having two like different elements. Only then it will be considered to be different. If there is just a permutation, then it will be considered same. Yes, it is always gonna be possible to have a number n. It is always gonna be possible to get n. And in the problem, it has also been mentioned that let's say if the flavors are like 1, 2, and 3, sorry, 1, 1, and 2, then he can only make two types of ice creams, 1, 1, and 1, 2. And there is a note which you can read. So please just confirm, is there anybody who didn't understand the problem? Okay, so let me read out the problem then. Okay, so let me read out the whole problem then in case if there is anybody. Tama decides to improve his ice cream making skills. He has already learned how to make ice creams in a cone using exactly two balls. Before his ice cream obsession, Tama was interested in mathematics. Therefore, he is curious about minimum number of balls he needs to have in making in different types of ice creams. So the problem is asking you to find out minimum number of balls. We will get to know about the balls in the like later part of the problem. And we have been told that we want to create n different types of ice creams. And then we have been mentioned here that let's say you are having flavors like these. So the only ice creams which you can create are by combining either one and one or one and two. You can't consider one and two twice. You will consider only them only once, and 1, 1 also only once. And in the here in this part, it has also been mentioned that 1, 2 and 2, 1 will be considered only the same thing. Um, Vignesh, it is not telling about the it is not telling about Indian Standard Time. It is telling in some other time zone. The time it tells here is not Indian Standard Time here. The contest started at 8:05 according to Indian Standard Time. So in the problem, we just have to find this. And note that Emma do not need to make all the ice cream cones at the same time. This means that while ice cream independently, also in order to make a following cone x, x for some x, need at least two balls of type x. So the problem is something like this. You have been given a number n. First of all, let's understand that if you are being given the balls like 1, 2, 3, then you can create ice creams of flavor 1, 2, 2, 3, 1, 3, and that's all. We can just create only these flavors. If you talk about 2, 1, it is the same as 1, 2. If you talk about 3, 2, it is again the same as this one. And the same thing goes for 3, 1 also. Both of these are also same. So you can ignore all of them. And the pairs will be like this only. So the way I thought about the problem after reading this thing was that I just thought about considering different elements because I want to minimize the number of balls required. So you can notice one thing that if I have something like 1, 2, 3, and in this set of balls, if I include one now, so only the pair of 1 and 1 will be increased. We will have all these pairs which you initially had, and you will have one more extra pair, 1, 1. But on the other hand, if you instead of adding one, like instead of including one inside the set, or like one more one inside the set, if you include a 4, so it will have many more pairs like 1, 4, 2, 4, 3, 4. This was the main observation that if you include a like new ball, a ball of new flavor, then in that case, more types of new ice creams will be there. But if you just include the same flavor which already exists, in that case, only one of the balls will be like one of the flavors will be increased. So I thought about in the problem statement, like in the example test cases, you can see for one, you can just include like 1, 1 or 1, 2 or anything. You need to have a set of two balls. For n is equal to 2, you need to have something like Let's see, what did it include? Okay, so for n equal to 2 also, we will require 3 of them, something like 1, 1, 2, 1, 1, 2. And in the problem test case, it was not 2, it was 3. So we will come up to this 2 also. For n equal to 3, we can have something like 1, 2, and 3. 1, 2, and 3 will have n, like if you say the number of elements in the set to be m, so it will be having m into m minus 1 number of pairs. You can just try to like confirm this or think about it yourself, that if there are m distinct elements inside the set and you have to choose 2 among them, so it is nothing but MC2, which is equal to m into m minus 2 like m into m minus 1 by 2. Yes, exactly. So let's take the example test case when n is equal to 179. What you can realize here is that till m equal to 19, MC2 is less than is less than equal to n here. Here MC2 will be equal to, here MC2 will turn out to be 19 minus 19 into 18 by 2, which is 161, 171 actually, which is 171. Yeah, so here it is gonna be something like 171. I need 8 more types. Like I wanted 179, I got 171, I need 8 more. If I include in the set of 19 distinct elements from 1 to 19, if I include a ball of 20, the number of flavors, like the number of types of ice creams will become 190, which is not desirable. I don't want to have more than 179. So there is no point of including a distinct element. What can I do now? What if I include a ball of type 1 here? Inside my set of from 1 to 19, if I include like 1 here, yeah, so only this pair will be new. All the other pairs with 1 have already been considered. So it will add just one more extra pair, which is 1, 1. So the number of um, flavors I've got will become 172. Now, if I include 2 inside the set, again, 2, 2 will be the only new pair. So it will become 173 and so on till I reach 179. Right. You can try to prove this also, that for it tells us that for any n, let's say you found some m such that MC2 is less than equal to n and m plus 1 C2 is greater than n. You found some m such that both of these condition holds. As for this example, when n was equal to 179, when m is equal to 19, MC2 is equal to 171, which is less than 179. But m is equal to 20 will have MC2 equal to 190, which is greater than 179. So here including a new element is adding m number of pairs, and you don't really want all of them. So you can just insert 1, 1, like just start inserting the repeating elements like 1, then 2, then 3, then 4, and so on till you reach n. Did you understand this? Guys, did you understand this? Yes or no?
Yes.
Okay, that's good. And yeah, talking about binary search. So in the problem, as you see that this n is equal to 118. So obviously you can't do the problem in big O of square root n or big O of n or big O of n square. You can't do it in any of them. Only big O of log n will work for every test case. So only this much can give you some idea that the problem might be done using binary search or some mathematics. Either it would be done in some mathematics using maybe like big of 1 at the end or big of log n, or with binary search. This is something at least you should think about whenever you see a test case like this one. Just wait a minute, let me charge my laptop. Okay, So now coming back to this problem, the very same problem. Here we had to include 179. We found that M equal to 19 is the largest M such that MC2 is less than equal to 19, like 179. How will I find this? How will I find the largest M such that MC2 is less than N, less than equal to N? Here you have an equation. You want to find the largest value of M such that this holds, and this M like N is constant. MC2 is always increasing if you increase M. So you can notice one thing, that let's say that there is some value of M here. Let's say M is equal to 21, such that this condition doesn't hold. You can easily say that for all the M which are less than or greater than equal to 21, they would also be false for them. Like if the condition is false for this, for M equal to 21, then it would be false for all of them. And if it is true for M equal to 17, then it would be true for all of the elements which are smaller than 17, right? This condition, this one. So in this way, we can like really prove that we can apply binary search here. Now for the part of applying binary search, I'm expecting you to already know about how to apply binary search by creating monotonic functions. And I will be just explaining you how I did it, but you already need to know about it. This is a prerequisite here. So the code is very simple. Just checking up for any value. Like first of all, taking the input. Equal to square root of n. Anshul, we can discuss about your doubt after the end of the session. This is not relevant here. Yeah, Siddharth, there might be some approach like that one also. You are just having a different equation. So we are first of all taking the input, then declaring a range. So the range is definitely like the value of this, the size of the set can never be smaller than 0, and it can never be larger than 2e9. There is no point of having anything different, at least for the binary search part. When you are trying to find M, such that MC2 is less than equal to N. So you know that you don't really need to search for M less than 0. You can directly say that M equal to 0 is always true. 0C2 will be 0 and N is at least equal to 1. So for M equal to 0, this is definitely true. The condition is definitely true. And for any M greater than 2e9, MC2 will definitely be larger than 1e18. So for them, I can definitely show that the answer will be false. So I can search inside this range only. Inside this range. Here the condition which I have used is including find of mid. So here find of mid is a function which I created, which is doing nothing but like I just pass on find of M and it returns me MC2, which is equal to M into M minus 2, M into M minus 1 by 2. So I've just modularized my code by creating a function so that I don't have to write this thing again and again everywhere. Though I just had to use it only at one place and only at two places. So you could have written it directly also. No, we can't create prefix arrays and it's very large here. Yeah, the problem was easy. You just had to observe this thing only about the duplicate part. And we are just applying a binary search here to find out the largest M. Now, when you would have found the largest M such that this condition holds, in our case, it was M equal to 19, for which we were able to get 171 flavors, but we had to create 179. And for increasing the count of flavors by 1, we have to increase the size by 1. So we would have to increase the size by 179 minus 171, which is equal to N minus find of M. So at the end, we will just say that rest plus equal to N minus find of rest also, and then just print it. No worries, try to do it on the next time. If you are able to think about the approach during the contest of this problem, then just do the implementation by yourself also, and by the next time you will definitely be able to do it. So let's move on to the next problem. Shall we move on to the next problem? Yeah, okay, so let's move on. Now we have two problems left, E and F. For the E problem, we have been told that recently Kolia found out a new movie theater is going to be open in a city soon. Which will show a new movie day for N days, and um, so it tells that you can read out the problem yourself. Let me tell you about it, the problem in brief. The problem says that we have been given an array A which represents the entertainment of movies. So there are n movies. There are n movies. The movie which is gonna be released on the ith day has an entertainment of AI. Fine. And let's say you watch a movie on day 0 and then you watch a movie on day 2. So you ought you had to wait for 2 days for the next movie. You had to wait for 2 days for the next movie. So you will get bored in as like 2 into D. It has been mentioned in the problem that the decrease in entertainment, like the longer the Kolia waits, the entertainment will decrease by D per day. So it is something like if you watch a movie on day 0, then watch a movie on day 2, then watch a movie on day 4, then the entertainment will decrease by 2 into T here, and it will reduce by 2 into D here. Right? Yeah, it's a greedy problem. Not exactly greedy, but yeah, it's a greedy, you can say. Like it's not involving any advanced topics. It's just simple stuff. So we have to, and we have been given one more thing, that we can visit at most M movies. We can visit at most M movies. So the observation here, the key observation was that I don't really care on which days I watch the movie. If I watch the movie, if the last day when I watch the movie is I, then summing up all the decrease in entertainment at the steps is gonna be equal to D into I plus 1. If I'm starting I is equal to 0, like if the first element I is equal to 0, then the total decrease in entertainment is gonna be equal to D into I plus 1. So that's it. The problem was only this much. You have to observe only this thing. What we can do is just say that find out the maximum entertainment you have, the maximum entertainment you can have till day I with at most M movies, with at most M movies, and then from this you just have to from this thing you just have to subtract D into I plus 1 for every I. Guys, did you understand it? That how it is working? Let's take let's understand this with an example. Let's take this example, maybe 666. 666. What is the 6? This is M. And what is this? Okay. Minus 82. 45, 1. 45, 1. Minus 77. Yeah, I will repeat it once again. So here One more thing which I wanted to discuss is that if any movie is having a negative sum, like if there is any movie which is not having any benefit for you, there is no point of watching this movie. You can just ignore it, right? If there is any movie with a negative like entertainment, there is no point of watching it. So either you can replace it by 0 while taking the inputs, or the other thing which you can do is just ignore this movie. Just ignore it directly. There is no point of watching it. So both of the ways are fine. Either you can replace them by zeros while taking the inputs, or you can manually handle it while finding the answer. Now what I say here, let's assume the array is something like 0, 4, 1, 0, 39, 11. Did you understand this thing? That if any movie is having a negative sum, there is no point of watching it, because we want to maximize the entertainment and it is minimizing it. Since we are not, there is no compulsion that we have to watch exactly 6 movies. We can even skip movies. So we will skip it. Now see till here. I just want to find the maximum sum I can have till this point, such that I'm picking no more than m elements. Picking no more than m elements. It's 0. For this element, this is 45. For this one, it is 46, because I can pick up these 2 elements, this one and this one, this one, this one. Till here, I don't really need to pick up anything, and the sum will be 46 only. I can just pick up these 2. Till this point, I can pick up this one, this one, this one. So the it's gonna be something like 85, I guess. And till here, it is gonna be 96. Since the m was 6, which was decently large, we actually just picked up all the elements and didn't really have to um, pick up selectively. But let's say if m was equal to 2 here, in the example, let's take m equal to 2. So the inputs were 45, 1, 0, 39, 11. Till this point, I could have just picked up 0. Like I could not pick anything. There is no point of going to any movie. My screen is freezed. Like, is it visible now, or is it still freezed? Guys, just confirm it once. Is it still freezed or is it good now? Okay. Is it moving or freezed? Okay, let's see now. Till this point, you can have a sum of like till this point, you can just pick up this element and have nothing. Till this point, you can pick up 45, which is the largest element layer. Talking about day 2, till day 2, you can have a maximum entertainment of 46 if you pick like you go to these 2 movies. Till this point, you can just again go to these 2 movies. There is no point of going in the next movie since it is having a lower entertainment. Till this point, you can go to 45 and for 39. These 2 movies. We are considering m is equal to 2, so we can only go to 2 movies. Let's not go to the movie with entertainment 1. Instead, go to the movie with entertainment 39. So we will have a sum of 84. Now coming up to this part, again the sum will be 84, because instead of going to this movie, we'll just still remain to only these 2 movies. So the problem has been reduced. Like for finding this part, the problem is just simple, that for every I, find the maximum sum by picking at most m elements. And if you replace these elements by zeros, so you can even like these elements by zeros, which were negative initially. So you can even say that we have to pick up the m largest elements till now for every I. Once you come up till here, once you form this array like 0, 45, 46, 84, 84 and 84. Once you form this array, okay, sorry, it's 45, 46, 45, 46, 46, 84 and 84. Once you build up this much, now you can see one thing. If you have your last movie till this point, then the like decrease in entertainment will be equal to 2 into D. If you have your last movie till this point, then it will be equal to 3 into D. If you have your last movie till this point, then it will have 4 into D. Similarly, 5 into D for this point till this point, and 6 into D till this point. Did you understand this, guys? Just please confirm me. Just please write yes or no inside the chat. Okay, that's good. Okay, that's good. So now we can just simply say that I want to find the maximum of all of them. Let's say that this is my array bi. I just want to find bi like maximum of for all the I, maximum for from I equal to 0 to n minus 1, maximum of bi minus d into I plus 1, which I can find very easily. So let's move on to the coding part. Let's move on to the code. Here I got a wrong submission in the first attempt because I forgot to use long. I forgot to use this long here. So in the code, what we have done is that just like first of all taking the inputs. Then after taking the inputs, we are like taking the array input, then declaring an answer variable, a sum variable, and a priority queue, which is a mini heap. It will keep then got d into I plus 1. It is d into I plus 1 because if I'm picking, let's say that if I'm having my last movie at this point, then it would be something like this. Like the sum of all the decrease in entertainments at every point will sum up to become I plus 1 into D. You can try to um, dry run your code maybe on a copy pen, and you can try to notice this that in the array, it doesn't really matter at which points I pick up the movies. The last point when I picked up a movie, if it is I is equal like any index I, then the total sum of that decrease in comfort entertainment will be equal to d into I plus 1. So that's why we are just subtracting it there. Yeah, that's good. So now we are just iterating over the whole array. If the array is having an like if the current element is positive, then just add it to sum and push it in the priority queue. Then check if the priority queue is having more than m elements. In case if it has, then just remove out the smallest element and it decrements the sum. And then just check answer is equal to max of answer and sum minus d into I plus 1. And then just print answer. So I hope that the problem is clear. Okay, that's cool. Now let's move on to the last problem. Rating for the problem. The rating has not been mentioned right now. We will get to see the rating after a few days. It generally takes like 3-4 days for the rating of the problems to be decided, depending upon the number of submissions. Now for the last problem, which we are going to be discussing today. Magic will save the world. This is a DP problem. The problem says that a portal of dark forces has opened the border. Like this is just some story, unnecessary. On the sorceress or sorceress, Vika can handle this. She possesses 2 magical powers. I'm glad that you liked the explanation. Thank you, Vignesh. So here we have she like Vika possesses 2 magical powers, water magic and fire magic. in 1 second, Vika can generate W units of water mana or F units of fire mana, and she will need to cast spells. Initially, Vika have 0 units of water mana and 0 units of fire mana. Then here we can see that there are n monsters, and everyone is having a strength of positive integer. To defeat the ith monster with strength SI, Vika needs to cast a water spell or a fire spell with at least the same strength. And in other words, Vika can spend at least SI units of water mana or at least SI units of fire mana on a fire spell. And the problem says that Vika create and cast spells instantly and can have unlimited number of cast like spells. So it means that she can defeat unlimited number of monsters in the same second if she has enough mana. And we have to find the minimum time she would require to defeat all of them. So let's see the problem here. According to the problem, we have been given an array A with some values, some random values, A1, A2, and so on. Let's imagine this like this, that there can be any values inside the array. She will have some fire mana, some water mana, with which she can cast spells. So for defeating all of the monsters, at the end, you know that at the end, what will be thing is, for some monsters, she would have used fire mana. And for all the other monsters, she would have used water mana. So the total mana she used is gonna be equal to the total strength. Like this is the total strength. So the intuition was that for every monster, you have two choices. Either you defeat it using fire mana or water mana. Either you defeat it using a fire mana or a water mana, right? In the problem, we can see the constraints that n is less than equal to 1e5, 100, and s is equal to 1e4, like less than equal to 1e4. So n is less than equal to 100 and si is equal less than equal to 1e4. We can say that the sum of all the strengths of all the monsters will be sum of s is less than or equal to 1e6. Right. This can be the total sum. So I know that for every element, I have two choices. Either I kill her with fire or water, fire or water, fire or water. So the idea was that just find out the combination which you can have. Like let's take an example here. 2, 6, 7. If the monsters are having 2, 6, and 7 as the mana. So in the problem, we have one more thing like 2 and 3, 1 for fire mana, 1 for water mana. I don't really care about which one for which one. I just care that for type 1, this is 2, and for type 2, this is 3. Now, the optimal solution here is that after 3 seconds, she would have 6 for the type 1 and 9 for the type 2, 6 mana and 9 mana. And with this 9 mana, she can kill this monster and this monster. And with this 6, she can kill this monster. So you just want to find out the total mana of this type and the total mana of this type she would require. And if you know about this thing, then you can easily find, like if I tell you that you want to have a total mana of total like water mana, mana, or I think the word was a little different. We don't really care about the spelling. The spelling might be different. The spelling might be wrong. If I say you that the water mana is equal to 6 and the fire mana equal to 9, then you can easily find what will be the time required to kill all the monsters. Like what will be the time required to have this much mana? Basically, you just need to find this because you have already like we will be having these values after finding that you need 6 manas of water and 9 manas of fire to kill all the monsters. And there can be a combination of like having 0 water mana and 15 fire mana, 2 water mana and 13 fire mana. There can be a combination of having like 6 water mana, 9 fire mana, maybe 7 water mana, 8 fire mana, and so on. You can have many combinations like them. So the idea is let's just find out all the combinations. How will we find the combinations? So this problem has now been reduced to a problem which is very similar, like subset sum equal to k. There is a problem which we do a lot of times, subset sum equal to k. It can be used. There are a lot of variety of problems on this concept where we just generate all the possible subset sums. Generate all the possible subset sums. So if you just generate all the possible subset sums, like in this case of 2, 6, and 7, all the possible subset sums are gonna be 0, 2, 6, 7, 8, 9, and then 13 and 15. 0 by not taking anything, 2 by taking this, 6 by taking this, 7 by taking this, 8 by taking 6 and 2, 9 by taking 2 and 7, 13 by taking 6 and 7, and 15 by taking 2, 6, and 7. You can find all the possible sums. Let it be equal to the water mana 1 by 1. The fire mana is gonna be equal to total sum minus is gonna be equal to total mana minus water mana. So you found the water mana, you found the water mana, you found the fire mana, and now you can just find out the time required to like build this much mana. It will be equal to seal of this water mana divided by W. The problem we have been given W and F, so it's gonna be W, that W. And for finding the amount required for fire mana, it's gonna be like fire mana divided by F. And in this way, we can actually find the fire like time required to build the water mana and the fire mana, and we will just take the maximum among them as the time required to kill all the monsters if we have this combination, and we want to take the minimum of all of them. So we will say that answer equal to minimum of answer and the maximum of time required to build the water mana and time required to build the fire mana. And at the end, we will just print the answer. So shall we move on to the coding part? Just please write yes or no, whether the problem is clear to you or not. Okay, so let's move on to the coding part. So DP state will be DP of IDX and sum till now. Yes, exactly. But there is one more thing. Yeah, there is one more thing. Here, n is less. Yeah, the n is less than equal to 1e2, which is just 100, and the maximum sum, like the total sum, is less than equal to 1e6. So if you try to create a DP of n and total sum size, you won't be able to create it. The reason is simple, that it will have a size of like 1e8, which is not possible. You cannot create a 2D array of size 1e8, or not even a 1D array. So what we will do is use the space optimized DP. We will do the problem with space optimized DP. So just creating like DP and NDP, just two DPs of size total sum plus 1. This is space optimized DP. Yeah, got it. Okay, so that's good. So the code is like this. First of all, taking the inputs. After that, like taking the other inputs also, the array, and finding the sum in the same loop. You can run another loop if you want. Then we are declaring the DP array, and initially all the sums are 0 by default, and we are saying that DP is 0 equal to 1 because you can have the sum of 0 by not picking anything. So DP 0 is equal to 1, and just generating all the possible subset sums. So we are just going to all of the elements of the array and just iterating over um, all the targets from the range of sum till a of I and d greater than or equal to a of I and d, because only those elements you can, like, by including the current element, you can have only these as the new elements. So let's have a try run. Let's say if the array was something like 1, 2, 3, 0, 0, 0, 0, 0, 0, 0, 0. This will be your DP array at the beginning. You set it to be 1 here. You set it to 1. Now in the first loop, when you are considering this element, so we will just see all the elements in this range, that if DP of tar minus A of I and D is true, which is true for this case, so we will just mark it true. And here in this case, this is only possibility. Now, when you consider 2, remember that I'm going from right to left, because if I go from left to right, then you can try to think about it yourself, that it will just set out every element to be 1. So now coming back, let's say we are talking about 2 though. So this element and this element have DP of tar minus A of I and D equal to 1. So we will just set them to be 1. And then considering the next element, all these three will become 1 by 1. And here in this case, all the combinations were possible. But what if the array was something like 1, 3, then 0, 0, 0, 0, 0. Here we will set it out DP0 to be 1 at the beginning. And when you consider this element, only this will be becoming true, because you can, if you can generate this sum till here, then you can generate this sum also by including this one. And these two will also become 1, because here that tar is equal to 3, and tar minus A of I and D, which is 3 here, is 0, which is set here. And the same case for this. Like, I haven't really explained properly how it works. This is pretty standard thing, which you can study in case you don't know. And this is very useful at a lot of places. And this is pretty optimized also for generating all the possible subset sums. Now initially I initialize the array as like answer as 1e8, which is never going to happen. Even in the worst case, you can just look at the problem constraints, that even in the worst case, the maximum sum possible is just 1e6. And like, even if you just use the water mana, if you're having water mana 1 per second and just use it, even in that case, you will have an answer of 1e6. So I initialize the answer with a variable which with something which will never be happening, so that it doesn't affect my answer. And then I'm just going across all the possible subset sums. In case if it is not possible, then just continue. If it is possible, then just find the water time, the time required to build up water mana, the time required to build up fire mana. this tar plus w minus 1 is nothing but the CL division of tar by w. And in this case, instead of tar, we will have sum minus tar because we will have to generate all the other mana as we discussed in the problem approach in notepad, like in OneNote. And then we are just setting up the minimum value in answer of the maximum time required here, because the maximum time you require is gonna be the maximum of the, like you will require the time with this combination as the maximum of these two. So we are just taking the minimum of all of them, and then we are just printing this answer, and it worked. So is the approach clear to you? Just please write yes or no inside the chat. Okay, that's very good. That's very cool. So I think that we can end the session now. And for the people who have been watching this on YouTube, you can go to the comment section and there you will see a feedback form. So you can just fill up the feedback form that whether you like the session or not. And you can give some suggestions on what you think which I should be doing from the next PCD onwards. And please make sure to give your valuable feedback, whether you like the explanations or not. And in case if you have any suggestion, then please mention it. And feel free to like the video and subscribe to the channel. So thank you for watching the video, and bye bye.